as with everything we've talked about, you have to have a way to control everything. The classical and the alternate pathways are based on cleavage of proteins, leading up to C3 and then after C3. Well, when you look at the regulation of the classical and alternate pathways, you have a C1 inhibitor that basically interferes with the ability of C1 to bind, for C1q to bind, for C1r and C1s to have activity. We've seen that this also is able to mess with the mannose binding pathway because there's such a homology between C1 as well as MBL. So it's not as good as an inhibitor for the mannose binding, but it's enough. So the C1 inhibitor keeps this from interacting and binding to self. C4 binding protein can bind C4b, displaces C2a, so you never have C3 convertase being formed. C4b, that's bound to the binding protein, acts as a recruiter, a stable place for factor I to bind. Factor I binds, cleaves. And then you go through and you see each of these different things can bind to and interfere with blank at some step up to the activation of C3 complement. And we want this. Yes, it may inadvertently interfere with it happening on the surface of a bacterial cell, but more often than not, it's going to interfere with the activation on the surface of self, or on the surface of one of your cells. So you go through and you look, there are numerous ways that we can regulate. Will this completely inhibit all? No, but it'll do it enough. So you see here, C1 inhibitor goes through, removes C1r, C1s. So you have the C1q still bound, but C1q does nothing. You can end up with the DAF, C4 binding protein, CR1, factor I can get in there and interfere with the alternate pathway. So even though this is a spontaneous activation, or I'm sorry, this can be a spontaneous activation, or you see here the result of the classical or the MBL pathway. DAF, factor I, can still get in there, interfere, and disassociate that complex. That complex disassociates, then no C5, no C6, 7, 8, 9 becoming activated. C5 convertase. So even if you do get a stable C4b, 2a, 3b, and complement 5 protein is recruited in, you can still have the dissociation of that complex before or after C5 is cleaved and 5a released. So things are not always irreversible. Here it's showing you that even if the complex, the cascade, is able to get a stable C3, C5 complex, and then you get the deposition of 6, 7, 8, and the recruitment of 9 until that pore is finished. Even if more and more 9 is being inserted, you can have CD59, which is conserved domain 59. It is a proteoglycan motif, a antibody, or was it a protein, sugar protein on the surface of all of our cells that will then interfere with the 5b, 6, 7, 8 complex. C9 dissociates and will actually be removed from the membrane. So nothing is permanent. So even if all this was to happen on one of your cells, at the final step, there is still the ability to stop everything.